Good morning. This recording is for Algebra 1, Chapter 8, Lesson 5, Factoring Trinomials of the type x squared plus bx plus c. And you're going to definitely see some variations of that today. When you're factoring trinomials, there's only really one way to do it, and that's called guess and check. I will teach you a shortcut a little bit later, but for now, guessing and checking, it's relatively easy. I recommend making a table to help you sort through your information, and yeah, it can be fun. It's a little bit more challenging. A calculator will help you go a little faster, but it's not guaranteed to get you the right answer because you kind of just need to use your brain. So welcome to Algebra 1. To factor a trinomial in the form of x squared plus bx plus c, you must find two numbers that have the sum of b and the product of c. Sum means to add, so you need to find two numbers that add to b and the exact same two numbers that when you multiply them give you c. Alright, you can use a table to help you organize your guess and check. Check your work by foiling. Alright, so first problem. And again, this is normally what I do over here in the blue. I think of two numbers that add up to b and the same two numbers that add up multiply to c, but the table might actually help you remember what you've done. Okay, so where the same two integers need to make both statements true. So we need to come up with two numbers that when you add them together give you g, and the same two numbers when you multiply them give you 10. I think we can do this. All right, so here are some ideas. So factors of 10, we can do 1 times 10, and we can do 2 times 5. Well, 1 times 10 is 10, but 1 plus 10 is 11, which doesn't equal 7. Because again, we're looking for two numbers that add up to 7, and those same two numbers, when you multiply them, give you 10. So, because basically I'm trying to find things that I can pull out. The thing is that the pullout's going to be a little bit messier than what you've seen recently. All right. So then 2 times 5 is 10, and 2 plus 5 is 7. And it's a little hard to see because I put there we go, check mark right in the middle. There you go, and 2 plus 5 is 7. Right? Right. Okay, so let's go ahead and plug this in. So I'm going to have two sets of parentheses. And right now, the first letter in both parentheses is going to be G. Okay? And I'm going to show you why this works in a minute. And then the next two letters are going to be the plus 2 and the plus 5. Because now if I go back and FOIL to check my answer, by doing the distributive property, by foiling, I should get where I started with the original problem. So let's go ahead and look. So we're going to double check by foiling. So G times G is G squared. Good. G times 2 is 2G. 5 times g is 5g, and 5 times 2 is 10. Combine like terms, and we're going to get g squared plus 7g equals 10. Hey, that's the original problem. Guess what? This means that my answer was correct and that my factoring was correct. So, if anybody asks you to factor g squared plus 7g plus 10, you know it's g plus 5 times g plus 2. There you go. All right, so let's go ahead and do this one real quick. What two numbers multiply together to give you 20, and those same two numbers when you add them give you 21? Well, that's relatively easy. It's 20 and 1. Makes sense. Some of them are going to be that obvious, guys, so try not to overthink them at first. You know, if you've gone through the obvious answers, then try looking at the non-obvious answers, because more than likely it's an obvious answer and you just missed it. Okay? So do think about all of the possible factors and all the possible sums that work. So there you go. Just plug it in. V plus 20 times V plus 1. And then if you were to FOIL, it will give you the original answer back, or the original problem back. Okay, now let's take a look at the type x squared minus bx plus c. Remember on the last slide it was plus bx, now we're dealing with minus bx. So some factor trinomials have a negative middle term and a positive constant term. If the middle term is negative, you need to inspect the negative factors of c to find the factors of the trinomial. So we've got x squared minus bx plus c. It means that a negative plus a negative gives b. Negative plus a negative is a negative. And then a negative times a negative gives you a positive c, which is why you're able to have a negative b here but a positive c there. and that's because of how this works. A negative plus a negative is a negative, whereas a negative times a negative is a positive. Make sense? Okay, good. All right, so let's do k squared minus 10x, k squared minus 10k plus 25. So what two numbers, when I multiply them, give me a positive 25, and those same two numbers, when I add them, give me a negative 10, and I'm sure you've already thought of them already. Well, negative 25 times negative 25 is positive 25, but when you add them, you get a negative 26, which is not negative 10. We want a negative 10, whereas negative 5 times negative 5 is a positive 25, and a negative 5 plus a negative 5 is a negative 10. So there we go. That works. So again, the two numbers that work are negative 5 and negative 5. So it's going to be k minus 5 times k minus 5. Or you can just write it as k minus 5 squared, because really that's what it is. When you have k minus 5 times itself, it's just twice happening, and since it's multiplying instead of adding, it's k minus 5 squared. And again, if you were to FOIL this, you would get your answer out. Okay, yes. All right, next type, we have x squared plus bx plus negative c, or just minus c. Okay, again, there's two ways to write this. It would be, no highlighter, x squared plus bx minus c is the other way you can write that, or plus negative c, because you can always add the opposite. Okay, so factoring trinomials with negative c. Think of pairs with a negative product but a positive sum. And here's your hint. Well, again, you're looking for a negative plus a positive equals a positive, and you're looking for a negative times a positive to equal a negative. And your hint is, since the sum is positive, the larger number must be positive. Okay, the larger number must be positive. Okay, the one furthest from 0 must be positive. Okay, all right, so m squared plus 8m minus 20. So we need to find factors of negative 20 that add to 8. Well, we have a bunch of these, and none of them work, as obvious, but this one does. 10 times negative 2 equals negative 20, whereas 10 plus negative 2 equals positive 8. So there you go. M plus 10 times m minus 2, and see how the 10 is furthest from 0, therefore it is the positive. Okay, let's go ahead, and again, you can always FOIL to check your answer, which I'm going to do right here. Looking good, looking good. Combine like terms, or you could always write it as that. There you go. But remember, it's the exact same thing as above, which means my factoring works. Yay, smiley face. Okay, the last slide. Aren't you happy this video is going to be shorter than the last one? The last one was insane. Okay, factoring trinomials with more than one variable. All the problems we've done before have only had one letter in them. Now we have two, but don't sweat. It's just as easy as the last ones. You just need to put the letters in specific places. Okay? So the first term is the square of the first variable. The middle term includes both variables, and the last term includes the square of the second variable. So, same as before, but includes the second variable. So here we have x squared plus 11xy plus 24y squared. So, when I'm factoring this, again, I'm still going to have two sets of parentheses. The x's go at the beginning because they were the first variable. Right. And it's the square of the first variable. So square, right there. And then the second variable goes in second. There we go. But now we need to figure out what numbers go in front of the y. So let's go ahead and do it the same way we were doing it before. What two numbers multiply to 24, and those same numbers, when you add them, give you 11. So 6 times 4 obviously doesn't work, but 3 times 8 works. 3 times 8 is 24, and 3 plus 8 is 11. So there you go. Just add, put in the 8, put in the 3, and you're good to go. And technically, for these particular problems, you could put the 3 where the 8 is and the 8 where the 3 is, and it's not going to matter, because if you check your answer by FOILing, you're still going to get the same answer. There you go. So that means my FOILing worked. And remember, your answer is the thing in the two parentheses. Okay, it's the thing in the box. Well, the top box, not the bottom box. This one. This is your answer right here. That's your answer, by the way, guys. I hope I wasn't confusing you by showing you how to FOIL. Okay, so let's do one last problem. We have m squared minus 17mn minus 60n squared. So this is like the last set where we have a negative and a negative. So we need to find factors that of negative 60 that have a sum of negative 17. Since we have a sum of negative 17, in this case, the larger number, the number furthest from 0, the number furthest from 0 should be negative, so that when we add, we still get a negative sum out. So, negative 15 times 4 doesn't work. Negative 60 times 1 doesn't work. But negative 20 times 3 works. Check that out. So we've got the m and the n. The m is coming first, the n is coming second. Both of them are present in my parentheses, and it's negative 20 and 3, which again, when you do some foiling, you're going to get the correct answer, which is the answer in yellow. Okay, I hope you get this. Again, it's a little bit of guess and check, this stuff right here, but you know what? You can do it. All right, I'm done. Bye, guys.